We're back on recording now. So what I'm looking for is your interest in your work. So things that you need clarified or help with. And I don't care what it is. I don't care how simple it is. Come on, guys. You must know by now that I'm not here to judge you. I'm here to help you. So there's no reason for anyone to feel as though they can't ask me the most elementary of questions about stuff that you've been doing. Okay, you must understand that we're in a good place as far as that goes. So I just encourage you to now ask for help. So you've got what I understand is you've got a tutorial. Have you had your first tutorial yet?
Yep.
You
First
have.
tutorial was last week.
So
Tutorial zero, as they
tutorial
called it.
zero. Okay. So I'm assuming that you went okay with tutorial zero, and you had some practice lecture questions as well, which was set up for you. So are there any questions coming from all of that? I guess. Does
I
this now
found,
make much more sense? I hope.
yeah, I found the dot product hard to get my head around.
Okay. All right. So let's have a look at what the dot product is all about. Now, one thing I will. Oh, yeah. Let's come. I'll leave that till the end. All right. Okay. So with our dot product, there's a couple of pieces of info in there, isn't there? There's a lot of information in the dot product. First of all, as a concept, what does the dot product do? So this is now. It's like me asking what's differential calculus. Okay, differential calculus is this. Okay, that's the concept. So what's the concept of the dot product? What does it do? What does it tell you? See how easy it is to get lost? You've had the lesson. That's a fundamental question, isn't it? It's a bit like asking what's multiplication. Okay, so the dot product tells you the degree to which two vectors are pointing in the same direction. Okay, so the dot, that's all it does. It just tells you to what degree are these two vectors pointing together. Okay, so that's all it's saying. It's an indicator of the degree to which they're pointing together. Okay, so the one that you were taught is the standout one, is the exception when two vectors are not pointing uh, in the same direction at all. Okay, uh, then we can say, now normally they have a little squiggle on top, or if they're bold, then you interpret them as a vector. So there's a few forms. There's a squiggle on top, or an arrow, and then sometimes there can be a squiggle on the bottom. Those three are forms of the same thing, but that's my attempt to be bold, which is quite ridiculous really, isn't it? But there you go. Drawing it bold A, and this one would be bold B, but it could have either of those forms. So A dot B, what's that? If they're not pointing in the same direction at all, what's that tell you? That's the one you would have picked. See how much information goes? Okay, that's the one. So if the dot product is 0, these vectors don't point in the same direction at all. Nothing to do with each other. Okay, so that begs the question, what happens if anything above 0 means that they are pointing to some degree in the same direction? What's the limit of that? Well, I'll leave you to think about that. All right, let's get back to the practicality of the dot product. Okay, now there are two forms of the dot product, and that causes a lot of confusion for students. Okay, one of them is A dot B. Okay, and the way that I'll cause this to be understood today, and I could probably be abused for this, but nobody's got to me yet. I'm going to use that phrase because it's often hard to know what to do with a product, a dot product of vector in component form. So there's my dot product, and this is A, isn't it? Okay, and B. So there's two forms, And often you have to work with both forms to get your questions out. Now that could be X, Y, Z, 1, 2, 3, it could be X, Y, Z. Okay. Now why have I put sum of products? Because you have to do this step. Often you have to do this step. Okay. So it's A1, B1, there's your product. Okay. Then your next is a sum. And then A2, B2. This was just off your notes, so nothing new here. A3, B3, sum of products. That's your first step. You're in component form. And I know that I'm in component form because those little angled brackets tell me that I'm in component form. Okay? And so that's that part. Now the other thing that we've got is that we've got the other form, which is A dot B is equal to these funny looking things, and we're going to have a bit of a chat about those today, and cos theta. So they're equivalents. So in a sense you can equate them. Okay? So it's a bit, when you do simultaneous equations, I often do, you know, if you've got two lines in there crossing each other, what's the point of putting y equals y? That doesn't make any sense. So there's no point in me putting A dot B equals A dot B, because that doesn't make any sense. But the sum of products form, and this is often not spelled out, but it's needed in your studies. So that makes a bit more sense. And what's the result of the dot product? This indicator, you would have had a phrase used, a word. What's the result? And you would have heard it as. So there's a new thing you've got to get used to now. A scale is just a number. See the concept, right? The concept of a number is easy. You've been doing it for 13 years. But when you call it something else, it's like, stop speaking Greek to me. I don't speak Greek. Okay, so we've got our two forms. Often this is what you end up needing to do. Okay, you end up needing to work with them in that form. So the other form here, we'll probably get to an example if I can, but these things here, what are the vertical bars? Because the vertical bars have got some big implications. If A,
absolute value.
You're not wrong in that, and depending on your training, and it's that field of analysis that doesn't get explored very well at school, what does it mean? Okay, so that's the algebraic interpretation. Now I've done this with you before. You're not going to say there's a... Yes, I am. And that's where the meaning comes from. Okay, so you've got that. You just called it absolute value, so I'll give you that, tick. But what I want to know is, what's the geometric interpretation of that? In fact, what's the geometric interpretation of that? Okay. Anybody?
Is it the magnitude, like the length?
Yes.
No.
Yes, that's part of the answer. That's part of the answer. Okay. If I plot this on a line, and I put origin here, and I put x, and the same distance minus x, this represents the distance from the origin. So in actual fact, when you see the vertical bars, the concept is the concept of a distance. This is going to come up multiple times in the next two subjects. So what I've got here then is a number line where I've got c, or x, and so I've got x, just making it a bit longer, x plus c, and x minus c. So what's the distance from the value x? It's the distance c. Now these are analysis ideas, and school doesn't go a long way to explaining a lot of things, and many of you are puzzling over this. But I know that you've met this before, but these are very important. Okay, so these conceptually are very important. So what this is talking about is the distance of something from something else. In this case, x from 0. In this case, x from c. How far away is c? I could make that c and do x minus c that way, but I'm not going to do that. So whenever you see vertical bars with a minus sign in it, watch out, because that conceptually is a distance. Okay? Now it turns out that this guy here is the same thing. It's an equivalent. And that comes up in statistics, in big data and all that stuff that you've learned about in the headlines. You know, machine learning and all that kind of stuff. So that's for Maths 2. And if you do Maths 2 in the summer, guess who's teaching it? Yours truly. Okay, so this one here, we're starting to talk about distance. And in component form, it's got these member sets, member values, that help paint the picture of where this vector is pointing to in all of those places. And we've done an example. You've seen that previously. And that's the vector A. Okay. Now, what's the length of that? What's the length of that? In other words, what's the distance? And the way that we denote that is that we put the vertical bars on. Now the vertical bars, and if we think about this as in triangular form, coming out from the origin and then going up to some point, we can think about that as being, and that's a right angle. I haven't drawn that very clearly, but that's a right angle, and so this length here is going to be dictated by the two sides, which is another problem altogether. But generally what they do is they just give you the formula. Now I always put things in brackets, people, okay, because you never know how these little numbers are going to turn up, but it's entirely up to you. Probably not in brackets in your notes, and that's okay, but that's just the way I do it. Okay, so we've got this vector denoted by the component form, and we want to know the length of the vector, and we do this Pythagoras. Okay, now it turns out, and that means that Pythagoras means this stuff. It's the length. Alright, so it turns out that when we're looking at vectors, we can think about a vector in terms of its unit self. Okay, so if we've got some vectors pointing around, you know, whatever they're doing, wherever they are in space, we can think about what does the vector look like from the point of view of having its components at 1. So what we can do is, what would that look like? That'd look like a little unit vector. This one here would be a little unit vector. This one here would be a little unit, say, have the same direction and everything, but it would be scaled. And it would be scaled so that it had its parts. Now, how do we find this? Now, this is something that you'll be doing a lot of, so we need to understand how to do this. So our unit vector has a hat on top of it. So this guy here is very important. The little hat tells you that it's one of these little guys. Okay? And if it's one of those little guys, then the equation that we take is that we take the vector and we divide it by its magnitude. And that has the effect of scaling it. So if you think about it, if we find out what that distance is, and we use that distance to divide the component form, what we're effectively doing is resolving everything to a unit vector. So this one here will have a couple of different forms. It could be this, and instead of having this, it might look like this. So just the different forms, the way they crop up when you're approaching those. Okay. All right. So let's have a think about now an interesting point about the magnitude of a vector, and there's something I just want to bring to your attention. I'm just going to do a little side light. I'll just call it a side light, side line, side light, something, or a note. We can just call it a note. Why don't we just call it a note? If the form of a distance between points or a vector, okay, so if we've got let's just do one. Oh, that's another thing we've got to do as well, isn't it? So I'll do this. And then the vector P to R. So you go to the outside one and you subtract it. That's what we'd be looking to do. Okay, so we'd be looking to take 7 minus 4 minus 2 minus 1 and 0 minus 0 in component form. So that would be 7 minus 4 is 3, minus 2 minus 1 is minus 2 plus 1, which would be negative 1, and that would remain 0. So that vector PR is expressed that way. So you go to the outside one and subtract it. So you might make a little note about that, because I'm not sure that information comes out in the lectures, but the next bit does, because what you're intended to do there is then go, well, what's the distance? In other words, what's the magnitude? And I'm sure you've seen this. And you've probably got it should have the arrow on the top in my view, but yours don't, so that's okay. PR, and then I think you were given to it like this. But that's just and so you would get so the magnitude. Now there's something that we're missing. Well, you know how we did the
Shouldn't it be 9 instead of 3?
oh, probably. Thank you. That's me being human. Dun, 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 dun. That's scary. Thank you for that. So what is it? 10. Okay, there's something that's being missed here. Do you remember this idea? And we said that was the important thing, and you had to go back to this form. There's something that I want to bring to your attention here. When the points aren't known and it's algebraic, so let's do P. P can be the same, 4 minus 1, 0. And are those going to be x, y, z? So then we'll get P to R and we go to the second one, x minus 4, square it, because it's algebraic, you see. Then we've got, go to the second one, y minus 1 is y plus 1, square it. And then, oh sorry, we don't need to square it at this point. Get it right, mate. So what did we say? X minus 1 is plus 1. Minus 1 is plus 1. And this one is z minus 0. Okay, and then finally what we're going to do, that's the form that won't change, is that if we take the magnitude, we'll get x minus 1 squared plus y. Who can see where I'm leading? Is it obvious yet? Okay, so that's the equivalent. Alright. The next thing then, so this seems like a strange form to have, right? But what happens if we square both sides? What happens if we square both sides? Well, what you'll end up with is undo. Who can tell me what that is? That's the algebra that goes with, what's the geometric interpretation?
A circle.
Yeah. So this comes up, okay, and it'll more than likely have some comment about being infinite in z, or some such thing, and so what you do is you get an extrusion. So I just thought I'd point that out to you because it's not obvious, and it's something that you've really got to spend time reflecting on in order to get it out, okay? Alright, so from your practice questions, we pretty much covered most of the practice questions, I feel. Alright, but we need to do a dot product example, don't we? So let's see if we can do a dot product example. Because I did skip that in my enthusiasm. Okay, so let's do an example. Can I do an example? So we'll do an example. So we're back off the note now. That was the note. Okay, so we got an example dot product. We'll assume they're bold. Okay. Okay, so we get them in unit form, and we're not happy with that because that's just an annoyance. Okay, so we're going to say that A, we're going to do a conversion and put it in component form. So the component form for A is that one, and for B it's going to be is that alright? Okay, so A dot B and it's going to be the sum of products. So 2 times minus 4 is minus 8. 2 times 0 is 0. And minus 1 times minus 8 is minus 8. So instead of being plus minus 8, I'll just put minus 8. Okay. And so we get an indicator of the difference in the angle between, or the direction that they point in, is minus 16. Okay. Minus 16. Then what I'll do is this is not in the example, but I'll say find theta. Okay. So to find theta, we need to do two things. We need to get the magnitude of A, and we need to get the magnitude of B. So this is 4 plus 4 plus 1 is 8 is 9. So the magnitude of A is 3. Now the magnitude of B is 16 plus 64. 16 and 64. I'm sure I can do it in my head on a normal day, but for the moment I'm just not there. 80, is it? 8 8s are 64. 4 4s are 16. They're positive, so we'll add them, so we get 80. Does anybody disagree with that? And it's going to stay as the square root of 80. Alright, now we know that A dot B, and I think this is what's probably causing confusion for you, has an equivalent form, and they're bold obviously, cos theta. So what we know is that the dot product from the component form is minus 16. The magnitude of A is 3. The magnitude of B is the square root of 80. And we've got cos theta. Okay. So what we need to do is divide. How do we undo? So we get minus 16. What you do to one side, you do to the other. Divided by 3 root 80 equals cos theta, or if you like, cos theta is equal to minus 16 3 root 80, because I've just producted them together. So therefore theta is going to be cos to the minus 1 and whatever that comes out to. So we've got 16 minus divided by 3. That's not what I did. 16 minus divided by 3 divided by 80 the square root of, and we'll shove that in the memory. Oh no, we won't, we'll just go cos of the minus 1, and we're in degrees, so it looks like 81.83 degrees. Okay, does that make sense? Yep. And so all of them are variations. Now look, it's the conversion, in my view, it's the conversion to component form, it's the magnitude, and yeah, have I done something wrong there? No, because the unit vector comes up. The unit vector comes up when you do your projections. Okay. So I think we're okay there.
I think I've missed something.
Yeah.
Putting through the same working, I got 127 degrees. I might have just missed a step.
So here I've divided by 3 both sides and divided by root 80 both sides. So I've got minus 16 over 3 root 80. Now it's not the cube root of 80, it's 3 times root 80. So minus 16 divided by 3 divided by all that product, however you want to do it. So is that where you think it's different? Is this the same on yours?
Yeah, I've got that the same on mine.
Okay, so let's just have a look and see. So 16 minus divided by 3 equals divided by root 80 equals. Okay, and then second function cos. Oh, I did something wrong. Thank you. Let's just do that again. This is what I thought I did before. Divided by 3. Actually, let's just try this. 3, let's just try this. 80 the square root. Equals. No, that's not giving me. Oh, that's what I did. I used the previous result. Yeah, you're right. 126. Thank you. I think just the way I was using that calculator was skewed. Because I've got to be more careful with that 0.6. Okay, alright. Did anyone have anything else that they wanted to go through? Now I think this week you start looking at projections and the cross product. Or have you actually already done that?
Yeah, that's this week's content.
Okay, so alright, so just watch out for that distance thing there. It's not obvious what happens when you square a distance formula and you're left with the geometry of a sphere or an extruded cylinder. Just looking quickly through the lecture, everything else looks okay. So just the length. Addition and subtraction, then you've done the dot product, which is an indicator. The number indicates the degree to which they go together. And interestingly, minus tells you that they're what does that mean? The minus 126 degrees is a big angle, isn't it? So that's like this. So 0 means they're 90, minus means they're going way apart. Okay, so that's good. Now you started doing your projections. Okay. All right. Are there any other questions? How are we going for info? Do we need to do what else do we need to do in terms of? I've given you a lot this week, but hopefully it's consolidating what you're learning anyway. So, has anybody else got any thoughts or questions they wanted me to do any particular thing?
In the recorded lectures, I was just a bit lost by the time they got to projections.
Okay, so do you want me to have a look at those as well?
Yes, please. That would be awesome.
Okay, let's have a look at those. Now, I think what I'll do then is I'll just stop the video because we're at that time, and then I'll start it up again. Just give me a second.